Good morning, my dear students. Today in these sessions, we are going to discuss first method of ellipse. The name of the method is eccentricity of an ellipse. First, read the question. Draw an ellipse. We need to draw the shape of ellipse. Clear? When the distance of it is focus from its directrix is given here 50 mm. So this means that we need to measure the distance from focus to directrix is 50 mm we need to measure, and eccentricity is given in the form of 2/3 ratio form is given. Meanwhile, we need to draw the tangent and normal to the ellipse at a point 70 mm away from the directrix. So here three condition is given. First condition is the distance from directrix to focus is 50 mm is given. Second condition, eccentricity ratio is given. Meanwhile, we need to find out the tangent and normal. It should be 70 mm away from the directrix line. First, we need to draw the vertical line. This vertical line is known as directrix line. We draw the vertical line. This vertical line is known as directrix line. No need to measure the length. What I am telling you here, draw the vertical line. This vertical line is known as directrix line. It represents as the point D and D dash. No need to measure the length. And represent here, this line is called as directrix line. So whatever the length you are taking, is it right? We have to take the median point. Here I am taking the length, how much? 18 mm. You take the center point should be 9 centimeter. Clear? From the center point, we need to draw one horizontal line. This horizontal line is known as the principal axis line. Draw the horizontal line from the median of the directrix line. Okay, so I am representing the point here A and B. This horizontal line is known as principal axis line. Clear here? Let us see. Vertical line is known as directrix line. It represents as D and D dash. No need to measure the length. And from the median point of the directrix line, draw the horizontal line. This horizontal line is known as principal axis line. It represents as the point A and B. Clear? Let us see this question. The distance of it is focus from its directrix is 50 mm. So this means that we need to measure the length from directrix to focus should be 50 mm. 50 mm we know that 50 mm nothing but 5 centimeter. So we can write here 10 mm. So what we can say? 1 centimeter. Are you agree or not? Yes. 20 mm what we can say? 2 centimeter. Similarly, 50 mm what we can say? 5 centimeter. We need to measure a length 50 mm, nothing but 5 centimeter. 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter and 5 centimeter. Just you need to mark. So this point what we can say? Focus point. Clear? Then after that, clear, A to F is 50 mm. So this point is called as focus point. Let us see. This A to F we need to divide into 5 equal parts. On what basis? The questions will be arise. Because of eccentricity ratio is given. If you add this value, 2 plus 3, nothing but 5. So we can say that the distance from A to F is how much is given? 50 mm is given. First we need to represent A to F is 50 mm. Clear? Draw the one line and reduce this line. This is called as arrow. How to draw this arrow? Let us see. Draw one vertical line. It should be away from this line. Okay. And you need to reduce this area. So this is what we can say arrows. Clear? This overall line is called as a dimension line. Clear? This A to F length is 50 mm. Divide into how many equal part? Divide into 2 plus 3, 5. 5 equal part. Each distance should be how much? 10 mm each. Is it right? Then A to F we are dividing into 5 equal part. Each distance should be 10 mm. 10 mm what we can say? 1 centimeter. 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. Any confusion? I hope so, no one. But we want vertex line. How you will get the vertex line? You will get the vertex line based on eccentricity formula. We know the formula of eccentricity equal to, it's a ratio of distance of a point from the focus, distance of a point from focus by distance of a point from its directrix. The ratio is already is given 2 by 3. Just we have to write 2 by 3. Clear? So this 2 what we can say vertex, and this is also vertex. So focus to vertex we need to measure how much? 2 centimeter. Let us see. Focus to vertex. We have to measure 2 centimeter. This is 1 centimeter or 2 centimeter. Are you agree? 2 centimeter what we can say? 20 mm. What we can say? This is 20 mm. This is 30 mm. Are you agree? Right. So this 2 centimeter we can write like mm. This is become as 20 mm and this is become as 30 mm. Clear? Focus to vertex is 20 mm. 20 millimeter. So this is what we can say vertex point. And show this arrow. Clear? And then again from directrix to vertex we need to measure as 3 centimeter, nothing but 30 mm. From directrix to vertex, let us see, 1 centimeter, 2 centimeter, 3 centimeter. This is the directrix line. This is the directrix line. Directrix to vertex is 30 mm. Clear? I am representing over here 30 millimeter. That after that the next step is we need to draw the arc. Let us see. We need to place a compass at vertex V. At where we have to place? At vertex V. Clear? Vertex V to focus we have to measure. It is visible for you. Let us see. Vertex V to focus we have to measure and draw the arc. Clear? After that the next step is we need to draw the vertical line. This line should pass from the vertex line. This line should touch on the top surface of the arc. So this point is called as the tip point. Clear? Then after that the observer is observed from A, the projection is moved from A to T point. The projection is moves in a upward as well as in a inclined direction. Let us see. A to T point. From A, we need to pass you need to extend this line. If you want to stop to this projections line, you need to take an angle of 45 degree from the focus line. You need to place a D scale where we have to place at the focus. At the focus, from this focus point, we need to take an angle of 45 degree. Clear? Then you need to pass from the focus point this line should intersect at a particular inclined line. If it is intersect at this point, from this point you need to draw the vertical line. This vertical line is known as the vertex V2. So what we can say here? Vertex V2. So this is the vertex V1 and this is vertex V2. We need to construct the shape of ellipse in between V1 and V2 only. Clear? Then how to construct? The next step is we need to mark the point. It should be away from the vertex line. You have to mark the random point. Let us see. I am marking the random point like 1. We are not measure any equal distance over here. 1, 2, 3, 4, 5, 6, 7. Clear? After that, you need to draw the vertical line. This line should touch from 1 to inclined line. Whatever distance you are taking, the same distance you need to take below the reference line. Clear? Same thing you can extend over here.